Okay, today we're going to move on in Lesson 4 to the terrestrial planets. Your Indiana State Standard is 6.2.4. Compare and contrast the planets in the solar system with one another and with the asteroids and comets with regard to their size, composition, distance from the sun, surface features, and the ability to support life. Extreme to the core. What are the terrestrial planets? I bet you're wondering what the word terrestrial means. If you ever have seen the movie E.T., it means E.T. stands for extraterrestrial. Terrestrial means of the Earth, like the Earth, rocky, solid, things like that. The terrestrial planets are the 4 small, dense, rocky planets that orbit closest to the Sun. In order by distance from the Sun, these planets are Mercury, Venus, Earth, and Mars. The terrestrial planets have similar compositions. That means they're made up of similar things, like rocks or metals, similarly. And they are made up of an outer crust, they have a central core, and they have a mantle that lies between the crust and the core. So let's talk about each of these 4 planets. Let's start with Mercury. Mercury is heavily cratered. It has a moon-like surface. It's made up mainly of volcanic rock, and it has a very large iron core. So the center of it is made up of iron, and it has a large inner core. Mercury orbits the Sun at a distance of 0.39 AU, or astronomical units. An astronomical unit is the average distance between the Sun and the Earth, or approximately 150 million kilometers. I did a little conversion for you on how many miles that would be between the Earth and the Sun, and it's around 93,205,678 miles, somewhere in there. That is a long way. So thinking about those numbers and thinking about 150 million kilometers, the math is very difficult to do. It gets very lengthy, and you can mess up easy that way. So astronomers, physicists decided that they would make a unit just for these large distances. So they decided that 1 astronomical unit would stand for the distance between the Earth and the Sun, and then we would measure things in space based on that distance. So 1 AU is how far it is from the Sun to the Earth, or 150 million kilometers. So since Mercury is closer to the Sun, it makes sense that its AU, its astronomical unit, is less than 1, 0.39. On Mercury, a day lasts almost 59 Earth days. So in 24 hours, we have a day. On Mercury, it would be more like 60 days, so 2 months almost for 1 day on Mercury. The daytime temperature can rise to 427 degrees Celsius, and the nighttime temperature can drop as low as 174 degrees Celsius. Negative 174 degrees Celsius is very cold, and of course 427 degrees Celsius, very, very hot. Mercury is the smallest planet in the solar system. It has an equatorial diameter of 4,879 kilometers. That means the distance around the equator of Mercury. What is known about Mercury? We know that Mercury's core makes up most of its volume, and its core is thought to be partly molten. So here's the center, the core, and iron. Remember, we talked that it was iron, a large iron core, and it's thought to be partly molten. That means somewhat melted. Harsh planet. Let's talk about Venus. Venus's diameter is 95% of Earth's diameter, and its mass is about 80% of Earth's diameter. Because they're so similar in size, Venus is sometimes called Earth's twin. However, there are lots of differences between the 2 planets. Earth has a prograde rotation, which means that it rotates counterclockwise about its axis, as seen from above the North Pole. So counterclockwise about its axis. That's called prograde. And Venus has what we call a retrograde rotation, which means that it rotates clockwise about its axis, as seen above its North Pole. So their rotation is in different directions. It takes more time for Venus to rotate once about its axis than it takes for the planet to revolve once around the Sun. So its year is shorter than its day. is what that's saying. The surface of Venus is covered with thousands of volcanoes, a very harsh surface, and so it has many craters. The average surface temperature on Venus is 465 degrees Celsius, very hot. Carbon dioxide in the atmosphere traps the Earth's energy, causing the surface temperatures to remain high. So it does have an atmosphere. It has carbon dioxide in that atmosphere that does not let the energy of the sun escape once it's in. It's hard for it to cool down that way. Sulfuric acid rains down onto Venus's surface, and the atmospheric pressure is at least 90 times that of the Earth. What's special about Earth? Earth is the only planet that can actually support life. Earth has liquid water. It has an energy source in the sun that's actually useful to us. It has an atmosphere that contains oxygen and many ecosystems for lots of different organisms to inhabit. So that's what we're talking about, different biomes and things like that. Matter is continuously cycled between the environment and living things. So we're constantly recycling that matter. Earth's oceans and moderate temperatures provide the ideal conditions for life to emerge and flourish. So we have this water source on Earth. Our temperatures aren't too hot, they're not too cold. You see that Earth's twin Venus even has a very high temperature of 465 degrees Celsius. And us, the next planet from the sun, we don't. Our temperatures are more moderate. Organisms that provide food and oxygen by photosynthesis appeared about 3.5 billion years ago, followed by more complex life forms. So 3.5 billion years ago, science tells us that things that created their own food were starting to show up. It's thought that between 5 million and 30 million species of organisms currently inhabit the Earth. So think about that, 5 million to 30 million organisms. Earth is the only terrestrial planet whose surface is divided into tectonic plates. So we've talked a little bit about tectonic plates. Tectonic plates are the plates that when they move, they cause earthquakes. Under the ocean, when they move, they cause tsunamis, which is an earthquake underwater, which causes the waves to react. The only terrestrial planet with those plates. Movement of these plates causes the continents to change positions over long periods of time. We talked about Pangaea and the land masses there. Tectonic plate motion, together with weathering and erosion, has erased most surface features older than 500 million years old. So those features that once existed 500 million years and before, we don't see any of those signs or pieces of evidence of what the Earth looked like then any longer. The moon has a surface gravity that's only about 1/6 that of Earth. So we've talked about this too, that when you go to Earth, your mass is the same, but your weight is different because of that force of gravity not pulling as hard on you. And the surface of the moon is also heavily cratered. Things have hit the moon over the years. The moon's surface has large dark areas that are plains of solidified lava, and then we also have the light-colored areas, which are what we call the highlands. All right, right now I want you to go to page 197 and read Earth is geologically active, then read Humans have set foot on the moon. I want you to observe the photo of the moon and then answer the question, visualize it. You have 4 things to do, so pause the video now and do that. The moon rotates about its axis in the same time it orbits Earth. Therefore, it keeps the same side facing the Earth. So you may not have known this, but we only see one side of the moon. Because of the rotation of the Earth, as the Earth orbits, the rotation of the moon matches that, and we always see the same side. The lunar day is a little more than 27 Earth days, so the moon's surface temperature can reach 127 degrees Celsius in the daytime, and it can fall to -173 Celsius at nighttime. All right, let's move on to Mars. Is it alive? The surface of Mars is composed largely of dark volcanic rock, and it is also littered with rocks and boulders, which are covered with a powdery dust. The dust is the product of chemical breakdown of rocks that are rich in iron minerals, and that gives the Martian soil an orange-red color. So as these rocks are breaking down, they're leaving this kind of powdery dust all over the surface of Mars, and it appears red because of the soil. The northern hemisphere of Mars appears to have been covered by lava flows, and the southern hemisphere appears to be heavily cratered. Mars has very large volcanoes and deep valleys and canyons. So we've got these big volcanoes and these deep valleys and canyons. Mars also has a thin atmosphere that's composed mostly of carbon dioxide. So another difference between the Earth and Mars, if you remember, the Earth also has what makes us special to be able to support life is the fact that we have an atmosphere that's good for supporting life. Unlike Venus, it doesn't trap the carbon dioxide and heat up our temperature. Mars has an atmosphere too, it's just thinner. During the Martian winter, carbon dioxide around the planet's poles freezes into this thin coating, and this coating vanishes during the summertime. So the carbon dioxide, the gas, freezes into a coating, and then in the summer it turns back into a gas. So I guess you could kind of think of this, remember we talked about sublimation? Could sort of be something like that may be happening there. The winds on Mars cause giant dust storms, and a number of features on Mars provide evidence that liquid water once flowed on the planet's surface and may be found actually beneath the surface. And we have rovers that are actually trying to find out the answer to that question. All right, I want you to go to Liquid Water Once Flowed on Mars, page 200, and read the section that says liquid water once flowed on Mars and answer the question and visualize it. You may want to look at the picture there too. Roving Mars. The Mars exploration rovers Spirit and Opportunity, so those are two different rovers, Spirit and Opportunity, have been exploring Mars since they landed there in January 2004. They are searching for evidence to show that water once flowed on the surface, and they're looking for environments in which life may have existed. The surface of Mars is made up mostly of a volcanic rock called basalt, which we can also find here on Earth. Basalt is a rock that we could find on Earth also. Okay, I want you to go to page 201 and read the section there, Roving Mars. Answer the extend and inquiry questions down here at the bottom, number 17 and 18. All right, this is the last thing you need to do for these notes today. Go to page 203, answer questions 1 through 7 and 11. 1 through 7 and 11. Also, please remember you need to fill out your visa. Visas could be used as pieces of evidence for your mastery questions if they are done well. Cannot write I have no questions or write some kind of thing about the summary of the notes was that I did the notes and did a visa. Remember, put some effort into it so it can count for mastery, and that also helps you understand this information better too.